Okay, so this is the last video for the 1.3 notes. So the last thing is, we've been talking about functions, we've done some different things with functions, we've described them, we've graphed them, we've found points of them. And so what we want to do here is to talk about, well, when do I know I have a function? Alright, well, there's two ways to do it. The first way is the graphical method, which is probably the easiest method. And then the second way is the verbal method. Does it follow the definition? More like what we did at the beginning of the 1.3 notes, but then with function expressions. Alright, so the vertical line test. Alright, the vertical line test is, if I've graphed my function, right, so I've done a graph of my function, and if I can take any vertical line, and it only ever hits my graph at least, at the most, or not at least, at the most, one time. So it can either hit it one time or no times, then it's a function. If the vertical line hits it more than once, it's not a function, because if it hits it more than once, there are two or more y values paired with one x value, which makes it fail the definition of a function. It's still a relation, but it's not a function relation. It's just a relation. Alright, so here's a couple of examples. This is a parabola example. Alright, parabola example. This is a yes, it's a function. This is not a function, right? Because this line hits it 1, 2, 3 times. And same thing if I did a line over there, it hit it 3 times, which means for that x value, there are 3 y values with it. A third case would be a circle. Alright, we talked about circles in the previous section, right? If I have a circle, it also fails, right? Circles are not functions. You can read that. It says not function. Circles are a nice relationship between x and y, so they are a relation, but they aren't related in a function way. They aren't function relationships. They're just a relation that happens to be a circle, but they aren't a function. Circles are not functions. All right, fails the vertical line test. All right, because I have 2 y values for this 1x value. All right, so that's graphically, vertical line test. If we're not given a graph, you could always graph. The hard part is graphing when it's not a case, right? Graphing a circle, or this case where it's not. And so what you have to do is, well, you have to make sure it satisfies that important line at the end of the function domain definition. All right, how do you tell if an equation is a function? Well, you could graph it and see if it is, see if it passes the vertical line test. And that's fine if you do it that way. Or you make sure this is true. All right, and for our simple examples right now, it should be fairly obvious when that's true and when that's false. For every x value I plug in, I get only one y value out. So the first example, if I have the equation x plus y equals 1. Well, if I solve for y, right, because I want my function to be y equals f of x, so that's what we do. We solve for y, so that's all we've done here, is that's my y value, right? I've solved for y. I've moved the x to the other side by subtracting it. I get y equals 1 minus x is my function notation then, right? We replace y with f of x notation. And so it does satisfy. If I plug in any x value, you can test a few. If I plug 2 in, I get 1 minus 2, which is negative 1. If I plug 10 in, I get y equals 1 minus 10, which is negative 9. Right? I get one y value out for every x value. And I can do as many tries as I want. None of them are going to fail. There's only ever one x value paired with one y value. Alright, so some more examples. So one of these is a function, one of them is not. Again, it should be fairly obvious. This is the first example where x equals y squared. Alright, this is not a function. The reason why is, again, the y squared is sort of the giveaway. Suppose I let x be 16. Alright, so I plug 16 in. I got 16 equals y squared. Well, if I'm solving for y, I use the square root rule, which when I use the square root rule, it's plus or minus 16. And so plus or minus 16 means there's two answers, right? Positive square root of 16, which comes out 4, and the negative square root of 16, which comes out negative 4. And so there are two answers, two y values paired with my 1x value. It fails that last definition. Right? Again, to give away that it's x squared. If you were to look at this graphically, right, this particular function, so I'm going to graph it down here, the y squared is a parabola that's opening up sideways. Right? And so it fails the vertical line test. The second example. I'm going to write it down here since I kind of written the space I have there. So y equals x squared minus 2. Y equals x squared minus 2. All right, make sure I wrote it down right. All right, so y equals x squared minus 2. This one is a function. You could graph it. If you graphed it, it's a parabola opening up and satisfies the vertical line test. Or you can just try, if I plug in x values, I will get out one y value. So x value of 3 would give me 3 squared minus 2, which is 9 minus 2, which is 7. If I plug in another one, it's still going to give me out one y value. Right, if you graphed it, you get the parabola. It should be this on your calculator, and it satisfies the vertical line test. All right, but again, functions should be fairly obvious. Circles fail because they've got that y squared term, right? I've got a x squared plus y squared equals 9. Well, that's my circle, right? That has a radius of 3, and it fails. Right? The y squared is why it fails. It's a relation, but it's not a function. Alright, so again, vertical line test is an easier way to go, but you can kind of look at them and tell if it satisfies that definition. For every x put you plug in, you're only going to get one out. Alright, and that finishes up 1.3. On to 1.4 after this.